Alright, ladies and gentlemen, I thought I'd put together a quick video on how to do a two-tailed tests for population proportions. And so this is our last example. I know we didn't have enough time the other day. So, according to the Center of Disease Control and Prevention, CDC website, 50% of high school students have never smoked a cigarette. Taeyoon wonders whether this national result holds true to his large urban high school. For his AP Statistics class project, Taeyoon surveys a simple random sample of 150 students from his school. He gets response from all 150 students, and 90 say that they have never smoked a cigarette. What should Taeyoon conclude? Give appropriate evidence to conclude your answer with a 0.05 significance level. So we're going to do all four steps. So state. Alright, and I'm just going to shrink this down just a little bit so it's not quite so big. I will perform a significance test. Let's widen this. And we are going to say H sub O. Let's see, here we go. So the null, oops, did I select the wrong one? Alright, the null will be P equals, well, let's see. If it was to hold up true, it would be the same, which would be 50%. So that means the HA, alright, is going to be, well, P is, well, we're going to go not equal to 0.5, and check out how I'm going to do this. You guys are going to be stoked. Check it out. Not equal to 5. Alright, because I just want to see if they are different. Alright, I'm going to put a few more things on here just so we've got everything where it needs to be here. And I'm going to say where P is the proportion of smokers at our high school. Alright, so just put in a little bit more context. Alright, next. Alright, we're going to do our plan. And so blow this up. Plan. Okay, and let's go normal, random, and independent. Alright, so let's do those tests quick. So is it normal? And the p-test is 10 successes, 10 failures. And let's see, I said 90 say that they have never smoked. So 90, that's 10 successes, that means 60 failures. So 90 successes and 60 failures means normal. Alright. And random. This is so fun, isn't it? Did I do a random sample? Oh, simple random sample. Yep. Alright. And, oops, oh no, that's not what I wanted. And I'm gonna miss Taeyoon. I don't know. Took a SRS of 150 students. Okay, and then independent, ENT, you would think I'd learn. Less than 10% of the population. And so do I have less than 10% of the population? I took 150 from his school. I don't know how big his school is, so I'm going to say yes, assuming his school has 1,500 students or more. Cool. Next. Do. All right. We are cooking with gas here. Do. All right, and here's where I'm going to start writing my stuff. So, I got 90 out of 150. So this is my sample. Right? Now, I'm going to pause and get my calculator. Alright, so I just did a few things. My sample that I got from my school was 0.6. Now, if we're assuming the hypothesis is correct, I should be messing with a normal curve centered at 50%. Now, I got a value of 0.6, which is up here, right? Okay. And so I'm above the average. So we will see how this turns out. So we're going to do a little z-score on this. So it's what I got, 0.6, minus what I should have gotten. If the hypothesis was correct, I should have gotten 0.5 all over, the standard deviation. Now remember, the standard deviation is based off of my normal curve. In my normal curve, the center should be at 0.5. So I'm going 0.5 times its inverse, which is 0.5 again, all over, and I did 150. So assuming that 0.5 is correct, what should be my z-score? Well, let's pause and find out. Alright, so I got a z-score of 2.449. Alright, so if I look that up in the book, it's going to be 2.45, roughly, really close to 2.45. Now, if I remember right, that should give me a p-value, so the probability of getting my result would be, doing something, I think it's 0.07. 007, my bad. 15, I believe. Okay. Alright. So it's 0.00715 if I look at 2.449. Now, that would be the area from here and above. Now, remember, I'm doing a two-tailed test, though. So I wanted to find the probability of just, could be greater than or less than. So I'm actually also looking for the probability below here as well. So, not only is it just 0.005 or 715, but it's actually another one of these because it's symmetrical. Alright? So I should have a total p-value. Remember, this is just the probability of 0.0143. So roughly a 1% chance. A 1.5% chance. Alright? So, in conclusion, where are we at? Alright. Conclude. Alright. In conclusion, here we go. So, two-tailed test, you got to remember. Taking the top, and I got to take the bottom. So, I'm really multiplying whatever p-value I get by 2. So, my conclusion. I received a p-value of less than 5%. And remember, 5% is where I'm drawing my line. I got a 1%. For my sample of 0.6. Therefore, I will reject the null and assume my school has a different proportion of students who, is it never smoke? It is never smoke, right? Never smoked. Yep. Never smoked. Proportion of students who never smoked. Period. Alright. Let's fix a couple of spelling errors. Cool. Alright. So just remember that two-tailed tests, you're going to do the same normal thing. Just make sure that you do one. When you figure out your p-value up here, you got to multiply it times 2 because you want another p-value down on the bottom. Alright guys, well, have fun, and whoever watches this, adios.